Hello everyone, and in today's video, we're going to see how to design a full ladder. So to know about the design of full ladder, you should be knowing the basics of digital electronics. Please go through my previous videos if you do not know any basics. Now, first step in designing the full ladder is to first write down the truth table. So here in truth table, since it's a full ladder, we're going to take three variables as input. A, B, and C are the three variables. And the two outputs for any adder is going to be carry and sum. For a half adder, in this case, we will be taking only two variables, that is A and B. But here for full adder, we will be taking three variables. Okay, so for these three variables, we should be writing all possible combinations of these three variables. So the all possible combination in the order of a digital system will start from 000. The second number will be 001, 010, 011, 100, 101, 110, and 111. Okay. So first we have written all the possible combinations of the input variables. Now we will go to the output side. For the output sides, we are having two outputs, that is the carry and sum. So first we will calculate the carry for all the variables and then we will go for the sum. Or sometimes maybe we can just calculate it side by side. That will be easier too. First, I will just calculate side by side so that it will be easy for all the beginners. So for A, B, and C, since it's a adder, we're going to add all the input variables. So 0 plus 0 plus 0. So according to binary addition, 0 plus 0 plus 0 is 0. So carry is also 0, sum is also 0. Second addition, 0 plus 0 plus 1. 0 plus 0 is 0, 0 plus 1 is 1. So this 1 is the output of addition. So it is nothing but the sum. Okay, since there is no carry, we will write a 0 in the carry. Next, 0 plus 1 is 1. 1 plus 0 is again 1. So the same result as the previous one, we have 1 as the sum. Since there is no carry, we will be having a 0 in the carry. Next addition is 0 plus 1, which is 1. Then 1 plus 1. According to binary addition rules, 1 plus 1. Okay, when we add two ones, we will get a sum of 0 and a carry of 1. Okay, so the sum is 0 and carry is 1. Going on to the next addition, 1 plus 0 is 1. Again, 1 plus 0 is 1. So sum is 1. No carry is there. So on the carry side, we will write a 0. Next addition, 1 plus 0 is 1. Again, 1 plus 1, we know according to binary addition, 1 plus 1, sum is 0 and carry is 1. So sum is 0 and carry is 1. Next addition again, 1 plus 1, sum 0, carry 1. And then same added to 0 will give the same answer. So carry 1, sum 0. Okay. Last addition, 1 plus 1, sum 0, carry 1. And then plus 1, this plus 1 should be added to the sum. So sum will be 0 for in this step. So when you add 1 to the sum of 0, you will get 0 plus 1 is 1. So carry 1 and sum 1. Okay, so this is the first step in the addition of full adder. Then we go to the second step, which is nothing but plotting of the K-maps. So we have to plot two K-maps for the two outputs, that is the carry and sum. So I hope you all know the basics of plotting a K-map, which will be easier before going for the design. Right, so first we are going to plot the K-map for sum. So since the inputs, we have three input variables, we will take a three variable K map. We will have A on this side and BC on the other side. And we will write the gray code combinations for A, B, and C. Now plotting all the sum and the carry variables. So where all we have 1 for carry, we should be checking that. So we have 1 when A is 0 and B and C are 1 and 1. So when A is 0 and B and C are 1 and 1, we have a carry. So this is for this, right? This is for carry. So when A is 0 and B and C are 1 and 1, we have a 1. Next, when A is 1, B and C are 0 and 1, we have a 1. So when A is 1 and B and C are 0 and 1, we have a 1. Okay. Next, when A is 1, B and C are 1 and 0, we have a 1. So when A is 1, when B and C are 1 and 0, when B and C are 1 and 0, we have a 1. Okay. And then last one, when A is 1 and B and C are 1 and 1, we have a 1. So when A is 1, B and C are 1 and 1, we have a 1. So we have plotted all the 4 ones in the carry. Now we can group into twos. So these two can form a group, these two can form a group, and then these two we can form a group and plot. So we will get AB plus BC plus AC as the result of carry. Now plotting the sum. Okay, when A is 0 and B and C are 0 and 1, we will have sum 1. So when A is 0, B and C are 0 and 1, we have a sum. Next, when A is 0 and B and C are 1 and 0, we have another 1. When A is 0, B and C are 1 and 0, we have another. Then when A is 1, B and C are 0, 0, we have another 1. So when A is 1, B and C are 0, 0, we have another 1. Last one is when A is 1 and B and C are 1, 1, we have a 1. So when A is 1 and B and C are 1, 1, we have a. So there is no possibility of grouping of ones in this K map. So each one has to be grouped separately. So after grouping each one separately, we will get the answer to be A bar B bar C plus A bar B C bar plus A B C bar plus A B C. Fine. So after plotting all those in the K map, we have the result, which is nothing but our equation. So the equation has to be expressed in logical form. So when you express the equation in logical form, you will get this type of logical diagram. So I hope this session was useful to you. Thank you. Meet you all in the next session.